On the leading strand, DNA replication moves along with the replication fork, continuously synthesizing the complementary strand and requiring all the leading initial primer. But on the lagging strand, polymerase has to go one chunks at a time, as new template is made available. These chunks are called Okazaki fragments. They're about 100 to 200 nucleotides long. Each one of the fragments requires its own primer in order for polymerase to bind and copy the new fragments. After each fragment is synthesized, DNA polymerase 1 will go through and replace RNA nucleotides from the primer with DNA nucleotides to make sure it's DNA all the way through. Because polymerase can join the last nucleotide of one fragment to the first nucleotide of another fragment, another enzyme called ligase has to go through and make sure everything is connected. Then, boom! We have now two copies of the original DNA molecule with A pairs with T and C pairs with G. Wait, there's more. DNA polymerase, it looks like it is excellent in getting the code right. It almost always puts the correct base across the template strands, and when there's mistakes, this enzyme can catch and fix this in a process called proofreading. How amazing, right? However, there is some point, 1 in every 10 billion base pairs, where errors ends up in the final sequence. But other enzymes or players of the game are to the rescue. We have enzymes such as, but not limited to, endonuclease and exonucleases that recognize these errors and perform mismatch repair, swapping out the incorrect bases and replace it with the correct one. Oh yeah, that's how DNA replication works.